Hello friends, welcome to my next video. This video is a continuation of index notation. We have done a lot about index notation, so in this video should be the last of index notation. So if you're not subscribed to my YouTube channel, please do subscribe so that you can watch all the videos concerning index notation. Now in this video we are going to focus more on on interesting topic, which is solving the equations involving indices. That will be our main focus in this video, solving equations involving indices. Now when we come to solving equations involving indices, there are two important equations that you need to know in this stage. Number one, we are saying the equations with a known index. The equations with a known index. An index is simply an exponent or power, meaning that the equation should be in this format. 3 to the power x is equal to 81. How do we solve this kind of an equation? So how we solve this kind of equation, it is very important to know, because this question will come in your paper 1 ECZ question examination or paper 2. Now in this kind of equation, the most interesting part is to solve for this value which is here, the power, the index. So another equation will come in the form of equations with an unknown base. When the base is unknown, in this the first one, the index is unknown, then you need to solve for this unknown index. But in this second equation, the base is unknown. So in this example, we have x to the power 5 is equal to 32. So we know the index, but we don't know the base. So how do we solve for the base? So these are interesting equations that we are going to look at in this video. Let's begin with the first equation of unknown base. Okay, so the unknown base, the first equation, we are saying that the unknown index or exponent. What do we need to know in order for us to be able to solve this accurately? We are saying that when the index is the unknown value, solve the equation by writing both sides as a power of the same base. Make the base on both sides of the equality sign the same. So meaning that in order for us to be able to solve for the exponent, which is the value of x here, we need to make the bases to be the same. So in this case, or in this scenario, we have 3 to the power x, we have 3 to the power x is equal to 81. How do we make the bases to be the same in this kind of equation? We need to solve for x. So the only way we are going to do is that this base, we cannot change this base to make it to be 8. We can change it to be 81, but it won't value, because we need to get rid of this x or find the value of x. So what we do is we are going to maintain 3 to the power x is equal to, change this base. What number can I multiply by itself and I'll be able to get 81? And the base should be equal to 3, the same as this one. So that will be 3 raised to what power? To power 4. 3 multiplied by 3 multiplied by 3 multiplied by 3, 4 times you're going to get 81. This base and this base is the same. So when the bases are the same, then we have already found the answer for the x value. So we just come and say, therefore now x is equal to 4. Therefore it means that you have solved for the x, you have solved for the value of x, and you have done your work. So this is how simple this equation is all about. That's how we go about it. Now let's look at the examples that you may want to solve and understand more. We have an equation 2 to the power x plus 1 is equal to 64. How do we solve this one? Same scenario. Make the bases to be the same and simplify the next part. So how do we make the bases to be the same? We are saying if 2x plus 1, there's no need of changing 2, because this is the lowest common factor we can have so far. So we need to change this one, which will be 2, of course, here raised to power what? How many times can I multiply 2 in order to get 64? That is 6 times. So if the bases are the same, then in other words, we are saying that work with the exponent, work with the powers. So we are saying x therefore plus 1 is equal to 6. Therefore, now here I can find the value for x, which is x is equal to 6 minus, when I get this, I take it the other side, it will be minus 1. Therefore, x is equal to 5. Done. Once you work it like this, then you have no problems in your exam. These kind of questions do come in your exam. Please don't take for granted, because once they do come in your exam, they will challenge you. Now, there's another example here, example 2. This one, you're going to finish it yourself. Having known this, you have to finish, which is, of course, they have given us saying 5 to power x minus 1 is equal to 125. So how do I simplify this? Change the bases, make the base to be the same. So this is 5, make also this side to be 5 raised to another power, and work with the powers. Once you are done, then it means that you will be excellent in your exam. Okay, you can pause the video in order for you to work this before me. You can pause. Okay, I'm sure it worked fine. And now let us confirm if you did the right thing. So in this case, we are saying 5, maintain the base, 5x minus 1 is equal to 5 raised to power 3. 5 times 5 times 5, 3 times, you're going to get 125. So the bases are the same. I work with the powers now. So I'm going to say x minus 1 is equal to 3. So I do the same, get this, take it the other side, which will be x is equal to 3 plus 1. Therefore, my final answer will be x is equal to 4. So this is how you work out this kind of equation. My final answer will be x is equal to 4. So if you do it like this, then you'll not have any problem in your exam. Okay, good. So we're done with the unknown index. So that's how you do when you're doing with the unknown index. Now let us go to another part where the base is unknown. When the base is unknown, how do we work it out when the base is unknown? Okay, so here now we come to the next part. When the base is unknown, how best can we work out this one? We're saying that unknown base. When the base is unknown, make sure you read this. When the base is the unknown value, try to make the index the same on both sides of the equation. So if the base is unknown, make the index, the index the same on both the sides. So for example, here we have x to the power 5. X to the power 5 is equal to 32. So the base is not known, but this other base is known. So what they are telling us is that make the index to be of the same. Make the index the same, in order for you to be able to solve this. So we are saying that x raised to power 5 is equal to, what will be the answer for this one? We are saying 2 raised to power 5. In other words, 2 raised to power 5, we are going to be, so it means we have raised the index to be the same. So if the index are the same, then it means that my final answer now will just be x is equal to 2. Done. This is how you solve this question. X is equal to 2 because the index are the same. So that is the only way. That's what you're supposed to do in this kind of equation when you're given the index which is unknown and the base which is unknown, but the power, you have a power here. So make the index the same, but once you do that, just get the value for x will be the base of the other power that you have, the other base that you have manipulated or solved here. Now let us continue. The other way you could use the following techniques to raise the side with the unknown base to an appropriate power. Now let us look at another example here. We are given a question of the same question. X to power 5 is equal to 32. What other ways can we solve this question to get the answer 2? Okay, that is our main interest. Okay, so the other way we can do it now is that since this is x to power 5, all we are going to do is x to power 5 multiply this power by 1 over 5, and what you do this side, also do it this side, which is 32 multiplied to 1 over 5. We have done it to both sides like this. Then it means that you have no problem. So that when you multiply 5 multiplied by this, you are going to get rid of this 5 and you just remain with x value. So we are saying x, this 5 and this 5 will go. we only have x to power 1, which is same as x. But this side is 32. So this 32 can be raised to a number, okay? We can simplify this further. We can say, how can we change this base? 2 raised to power 5 is equal to 32. Therefore, now we can still simplify this by 5 multiplied by 1 is 5. 5 into 5 is 1. So x, therefore, is more like x is equal to 2. So this is another method we can use apart from using this method of changing the base here. We have done it. We went direct. We make the index the same. But here we didn't make the index the same. We just multiply the reciprocal of 5 of this base of this index, and we get our final answer like this. So you can use this method, whichever method you feel comfortable. It will be all for your advantage. So a lot of questions will come for this question. Now let's look another good example that you may find challenging in your examination paper. Now you have a question, you have an example like this one. 5x to power 1 over 2 is equal to 45. So how do we work this kind of equation? So what we do in this kind of equation is, because we want to make x the subject of a formula, so we are just going to get rid of 5, this 5 here, which we're going to divide both sides by 5, even this side 5, so we cancel this. Therefore, we have x to power 1 over 2 is equal to, what is 5? 5 into 45, which is 9. So it means that we have gotten rid the coefficient of x. And now we need to get rid of the power so that x can be on its own. So how do we do it? We are going to say x 1 over 2 multiplied by 1 over 2 on both sides, which is 9. We are going to multiply it with 1 over 2 so that I can get rid of this power. Okay, so this now comes to be, this now will come to be x. So this power 1 over 2 is one and the same, so we can get rid of this 1 over 2 there, and then it means that you'll be able to get, okay. So now we are simply saying that all I need to do, if this is 1 of x is 1 over, and then we are going to not 1 over 2, but the reciprocal of 1 over 2, which is 2 over 1, which is, even this side we say 2 over 1, which is same as 2. So when we set x to the power 1 over 2, this is same as 1 multiplied by 2, which is 2. 2 into 2 is 1. So we leave it like that. But this side, we're going to simplify it further. We're saying if 3 raised to power 2, and this side we're going to multiply with 2 there. Therefore, we have x is equal to 3. 2 multiplied by 2 is 4. So 3 raised to power 4, it means that 3 times 3 times 3 times 3 times 3, 4 times you're going to get 81. So this will be the value for x. So this is how you do this kind of equation when it comes in an exam. These kind of questions are very important and very tricky. Once you make a mistake in one step, then you cannot find the value of x. Hope this was very helpful. We shall meet in the next video that we shall look. And for today, let us end here, so that next time we shall do more practical work. So if you're not subscribed in my YouTube channel, please do subscribe so that next videos cannot be a problem, or you can easily get a notification so that you can follow along and get your understanding uplifted, so that your exams can be easily done without any problem. Thank you, God bless, and thank you for watching.